So if you look here, we had used the Z pulse, hence the alpha value was 60. Okay, but what if you have number of pulses per second? Okay, like our PPR is 500 PPR, the encoder I'm using. So if I use the A pulse, I will get 500 pulses per second. More number of pulses are coming per rotation. Okay, so how the alpha value is going to change? So let's say I'm having a disk which is having 4 detection levers, you can say, and say this disk is exposed, this disk is being sensed by an inductive sensor. Okay, so in that case, when this disk rotate complete 360-degree, okay, the inductive sensor is going to give me 4 pulses. So my alpha value will be 60 divided by 4. Okay, in our case, my encoder is giving me for one complete rotation 500 pulses. So my alpha value will be 60 divided by 500. That comes out to be 0.12. So this will be my alpha value if I'm going to give more number of pulses per rotation. In our case, PPR is 500. We have calculated is 0.12. So as per your PPR, you can do calculate the alpha value. Okay. So if it is 0.12, how I can enter the value in PSC, AH and AY? So in Mentisa, I can enter the value like 0.12, and in exponent, I can enter the value 10 raised to 0 or 1.2 10 raised to minus 1. So whatever, the final multiplication should be 0.12. Okay, so let's see. I'm going to enter in Mantissa 0.12 and in exponent 10.0. Okay, if you have missed what I'm talking about Mantissa and exponent, so these are the things. So I'm going to enter in A, the Mantissa as 0.12 and exponent as 10, 0, 0. Okay, let us do the same, and also I'll change uh, the wiring connections. Instead of Z pulse, I'll wire up A pulse now. So here I'm also changing the wiring part from Z pulse to A pulse. Also, let's change the parameters. Parameter group to PSCAH will be 0.12. PSCAY will be 1000. Okay, now let us again simulate the RPM value through the PLC. So you can see right now the velocity is again 1500. So it was 180 RPM. Okay. So let's again rotate the motor with the same RPM, which was 180 RPM. Okay. And we can see the pulse meter is showing us 180 RPM. Okay. Similarly, if I try to reduce the velocity, let's say 1000 pulses per second, that means 2 revolutions per second, and in terms of minutes it will be 120 RPM. Okay, vice versa, if I now check it with